price performance on SQL serverless. One of the claims that I've seen from some of the competitors that will not be named here is around concurrency, right? Like I've done some tests in the billion rows range, and mainly for me as a single user running those tests, I've publicly posted everything there so everyone can nit anything they want to nitpick from my methodology, right? But one of the consistent claims has been around concurrency. Now, the flip side, I've also seen a lot of claims about concurrency from Databricks, about concurrency being better with Databricks. From a technical perspective, perhaps ignoring the platform back and forth, but just from how does Databricks do with concurrency around SQL serverless warehouses?
So back in the day, which in our terms would have been like probably 2019. So before SQL warehouses came out, when I joined Databricks, there were just clusters. There was all purpose and jobs. That's it. Back then, when you had one Spark cluster, it was the original mode was what we call FIFO, first in, first out on the scheduler. So you spawned a cluster and you give it a job. It did everything on that one job, right? It just focused one thing at a time. And it didn't really do multi-user, what we call concurrency. So concurrency, just for everybody's sake, is how many concurrent commands or users can my system actually take at the same time and still maintain a high level of throughput? I have a friend at Databricks who's got this great explanation that he gives for it to kind of like trick the mind into understanding some of the marketing nonsense that goes along with concurrency, right? Because a lot of times customers want to maximize concurrency, right? So that's kind of like the thing. So this concurrency number, like how many concurrent queries you can have, becomes a real sticking point. And even in our own history, it just happened because the PM team in charge of Databricks SQL in its very early days needed to pick a number. They're like, well, how many concurrent queries? I don't know, 10. There wasn't really a whole lot.
There was no science to it.
There wasn't a lot. And at the time, another cloud-based data warehouse default was 8. And so they said, 10, we'll do 2 more. But they also let you configure, but that's a different story. So we ended up actually backtracking that number, but that's how sensitive people are about concurrency. They get this number in their head, is it 8, is it 10, is it 12? And then they limit their thinking around that. But this is the cloud. When you were on-prem, the number of hardware that you bought, like however many servers, you were stuck with that concurrency number until you bought more hardware, right? So concurrency on-prem was a big issue because you needed to plan for it. Concurrency in the cloud, we just spin up more virtual machines. Like, it's not a big deal anymore. So this concurrency thing, I think, is blown out of proportion. It's not really that big of a deal. I think it's a red herring. It's kind of something that these competitors use to kind of like make customers think that they're better. But really, in the cloud, we just spin up more virtual machines to handle it. One of my colleagues likes to say, when a customer was pressing him about the number, I want to know the number, I want to maximize that number. He's like, okay, listen, imagine you're trying to get, 5,000 people from New York to London. A cruise ship has a max concurrency of 5,000, but it takes 2 weeks to get there. An airplane has a max concurrency of 250, but the flight is only 9 hours. Which is going to give you the better throughput for getting all those people to where they need to go? But the ship has a max concurrency of 5,000. Isn't that better? It's going to take you 2 weeks, right? Whereas you can fly the people back and forth much faster for a total time. We call that the total time it takes to move 5,000 people, or in our example, amount of data from one place to another, throughput, right? What we're trying to do is maximize throughput. Concurrency is just a knob of how many can it do at one point in time. So like, that's how we should be thinking about concurrency. Now, to address like the elephant in the room.
And by the way that I would probably go about explaining is, I have a large family, so I think about things in this way, but you have one sink, 5 people are trying to wash their hands. Sure, you technically can. It's just gonna take a little bit longer between everyone just trying to take a little bit of the water to do a very good job. Or if you have 5 different sinks, or one goes after the other just in the right order. And I think this kind of comes back to another point, and that is one of the reasons why I try to be very open with my testing as to how I do things is because realistically, anytime you're doing any testing, you can always build things in a way to go one way or the other.
Yeah.
That could happen for anyone, and I'm cover your ears, but I'm sure all competitors do. But at the end of the day, that's for me, that's why I value publishing the things that I do openly, so that, because I know there's gonna be holes in whatever I do, not intentionally, but I know there's always gonna be holes.
Sure.
Which brings me to the point too, that ultimately, if you're someone evaluating a platform, test it out yourself.
Always. What I would stress to people that understand is that this concurrency problem, when you're dealing with dynamic compute allocation is a very hard problem to solve. We have been trying to optimize an algorithm to understand, so we call it adaptive routing and intelligent autoscaling, where depending upon the incoming rate of queries and the current weight of the queries in the cluster, will dynamically scale to maximize throughput, which also will give you more concurrency over time, right? And even the smartest engineers in the world that we employ, we're still perfecting it. Like there's still edge cases that come in. So even AI that can act split second with all of the relevant data at that moment in time still struggles to kind of like optimize and maximize the throughput number near infinite resources, right? So smartest engineers programming the AI can't figure it out. If a vendor gives you the knob to control concurrency, and they're like, oh, well, I mean, just put it up. You want more concurrency? Increase it, right? Just increase the number. If it's 8, make it 12, 24. There you go. More concurrency, right? It's great. And in some tests were to, I don't know, make it give it a lot of small queries and just increase that number, they can say, look, I can give you more concurrency, right? What I would say to you then is that what they're doing, imagine our scenario where we have a family of, how many kids you got? How many?
I got 5 kids.
So you've got 7 people. You got 7, how many bathrooms do you have?
3.
3. So you've got 7 people in 3 bathrooms. That means you have a max concurrency of 3 bathrooms, right? And let's say you're with this vendor, I don't know, that allows you to configure that number. Like your hard number is 3, right?
Yeah.
And they say, no, we're gonna make it.
You can make it work.
6, right? How are you gonna do that? Well, 2 people at the same time in the bathroom, right? Well, because you can share the resource.
Yeah, that makes sense, yeah.
Does that make sense? But can 2 people use the same toilet at the same time?
No.
What happens when you try to mess with that number as a human, you get resource contention because you can't change that number dynamically over time, right? So what happens if the queries start coming in bigger? What happens if they start coming in smaller?
Yeah.
That number is such a moving target, you really can't hit it. I think to kind of get to the point, right? Like, we don't think that manually setting a concurrency number is the future. What we think is that you have to react in real time to the demands of the business. What demands are they putting onto your warehouse? And the warehouse has to figure out how to scale itself in order to handle that demand. And that's what we're doing. That's what we're building. Now, when our customers test our concurrency versus our competitors at high scales, I'm talking not the pretty stuff they like to do in their POCs, like 10 users. I'm talking 100 to 1,000 users. We pull away from our competitors tremendously. But I want to say everybody is working on it in these problems in this space. So our competitors are catching up to kind of where we are now because we kind of set a new standard. But I think we're going to continue pushing this envelope of like, how can we get smarter systems to manage that concurrency? Because really what customers want is they want their queries answered really fast and they want to pay for only what they use. And they don't want to pay for a whole lot of extra resources. So how do we just in time deliver the right amount of compute to handle those
The least amount of knobs.
with the least amount of knobs? I think that's what we're working on, and we already have the algorithms, and now we're just fine tuning it with customer workloads.
That's all the questions I had for you.